Good morning, everybody. Good morning. I want to thank you all for coming out. As you know, this is the second coming of the State of the Center, because our first one was during the big snowstorm. So I appreciate you all changing your calendars, coming out. My name is Robin Frankel, and I'm chair of the Friends Committee. So it's my pleasure to welcome all of you here today. Very briefly, I want to tell you who the speakers are going to be in order, so you can keep tabs. First, we'll have Dr. William Danforth, who's chairman of the board, followed by Sam Fiorello, who is our chief operating officer and senior vice president, and also president of the BRDG Park. We have Dr. Phil Needleman, who has been the interim president since Roger Beachy left, and Dr. Jim Carrington, who is the incoming president, who will start on May 1st, but obviously he's here today, so he's sort of starting already. I wanted to tell you that after the remarks from our presenters, there will be an opportunity for questions, and there will be people going around with microphones, and please flag them down so that if you do ask a question, you will be able to be heard by everybody in the audience. I also wanted to just quickly remind you that tomorrow is a conversations program, and that's at 5:15. Right here in this place, and the topic is biotechnology in the United States, balancing regulation, research, and scientific discovery. I also want to ask any of you who are not friends of the Danforth Center to consider becoming a friend. You can become a friend for $100 or more, and we'd love to have you part of our exciting organization. And now, without further ado, Dr. Danforth.
Thanks, Robin, and thanks to you and the Friends Committee for doing such a great job for us. And welcome. I'm very happy to see this turnout today, particularly since this is going to be a lot of good news we're going to report. So it's very nice to see big crowds when we have good news. At this annual meeting, we usually report to our friends and supporters on the highlights of the last year, the minuses as well as the pluses, but this year there are more pluses than minuses, so I'm happy about that. Last January, one of our board members, Phil Needleman, was serving as interim president while Roy Vagelos led the search for the permanent successor for Roger Beachy. While waiting for the next president, we delayed new appointments so that the president would have a chance to make them. And as the year then went on with fewer scientists than was normal, fewer principal investigators than was normal. Nonetheless, 2010 was very successful. Thanks to Phil, who has been an amazing president, shepherding through many improvements and helping all to work well together. He so impressed the community that he is now interim president of the St. Louis Science Center, and that we call interim president squared. And there's no more talented person in St. Louis, and I'd just like to give a hand of appreciation to Phil Needleman for his leadership in this last year. Thanks to the scientific and administrative staffs who carried on so effectively during a year of change and uncertainty, the funding from competitive grants grew, despite the smaller group of principal investigators. Thanks to our volunteers and our friends, and the Friends Committee led by Robin Frankel, our programs and annual support grew. Thanks to Laura and the junior board and all who made possible the packaging of 355,000 meals on World Food Day and sent them to Africa and made the event such a fun and learning and exciting experience. Thanks to Roy Vagelos, who led an unusually successful search, consulting with the leading plant scientists of the world on the future of plant science and who would be our best leader. But the years, so in sum, thanks to all the great people who pulled together this last year. The biggest highlight, of course, was that Jim Carrington agreed to be our next president. The news was greeted with enthusiasm nationally, internationally, in St. Louis, those who have met him, who are not plant scientists, among our friends, and most of all, I would say, the enthusiasm was greatest in this building. In the enthusiasm among the scientists, among the staff, and everybody who works here. So that does not always happen with a new person coming in. More about Jim and from him later. Finally, in January, the Danforth Foundation announced it was making its last major gift, $70 million, to the Plant Science Center, and then would be shutting down after 84 years. It's a fitting finale for the Danforth Foundation that had been funded by the successes of a food company, Ralston Purina Company, and a family that was devoted to serving farmers and producing healthy foods for many, many years. The closing was no surprise, since the foundation had for years been spending from capital with no intention of lasting forever. And as I have confessed to some of you, I learned one financial fact, that if you give away too much capital for too long, you don't have any left. And we proved that theory to be true. The trustees believed that a successful Plant Science Center was the greatest and most fitting legacy that the Danforth Foundation could leave to St. Louis and to the world. The biggest surprise to me was how many people in St. Louis have received this news very positively, and how they've spontaneously thanked me for the decision and for the gift to St. Louis and its future. I believed that to be true, but I was surprised at how many others did as well. Now I'll just take a few minutes to tell you what I think this gift means and does not mean for the Donald Danforth Plant Science Center. It does mean that our endowment will grow by $70 million, that is by just about a third. It will permit Jim Carrington to take the next steps to fill this building with scientists and bring us not just new research, but in my layman's terms, a whole new approach to doing research, including the handling of vast new information now available. These additions should speed up research in a way that I at least could not have imagined even a few years ago. I remember when I was doing research that I would line up my test tubes and my pipettes, and I'd work away for the day, and in the evening I'd get out my 15-inch slide rule and calculate all the results. And you know, it's very old-fashioned. That's not done anymore. In other words, our power to pursue the goals to do good for the world and for St. Louis will be greatly enhanced. It's a sea change in my view. Where we'll end up, I certainly can't foresee, but what an opportunity we have. It just seems to me almost like a miracle. Selfishly, I'd hope that we might relax a bit and think about the future, but that's not to be. The future is here. We've not yet reached the promised land. We've only reached another plateau from which we can see the mountain that we have been dreaming about for the last 12 years. I think often of Norman Borlaug, the father of the Green Revolution, that trebled the production of cereal crops per acre, and that spared from starving 1 to 1.5 billion souls, it's estimated. If anyone is our patron saint, he is. He had the advantage of pioneering a new intense approach to improving plant productivity, relying on breeding from stocks around the world, fertilizers, irrigation, and other improvements. He didn't have today's science, but we do. And there are two major differences, I think. One is today's tools are to his tools what the abacus is to a laptop computer. And secondly, the problems that are pressing on us, humankind continue to grow, and of course they speed up as well. World population has more than doubled, almost trebled since the heyday of the Green Revolution. Over 1 billion people will still go to bed hungry tonight, and on average, of once every 6 seconds, a child will die of the effects of malnutrition. And the environment that sustains us and provides the abundance that we've enjoyed for so long continues to change, speeded up by the increase in the use of water and fertilizers as a part of the Green Revolution, and especially by the worldwide pursuit of stronger economics, so that for the first time, our species has the numbers and tools not just to threaten the local environment, which has been done since the real dawn of civilization, but to threaten the world's environment all at once. So we can't relax. The opportunities are greater than ever. And besides, there's no other institution just like ours doing what we can do, that we expect to assume our responsibilities if we fail. Our job is getting more rather than less challenging, but I guess that's the way life is at its best. The next mountain is harder to climb. I've heard from one of my old colleagues in the medical school, there are really two types of people. Those who say challenges, gosh, I'd rather do something else. And those who say challenges, that's what I was made for. So I suspect the people in this room belong to the second group. So how lucky we are to be at a place where making the most of our opportunities requires our best. Finally, in answer to those who might wonder, is my $1,000 or $100 or less really helpful in the face of a $70 million grant? The answer, of course, is yes. Our budget on this new plateau will be more rather than less difficult. The world, especially with the world economy the way it is, we're going to have to budget conservatively. We'll still be asking ourselves repeatedly, can we afford this piece of equipment or this raise, or to invest in this promising young person, or carry a new plant to Africa? That's the way life is. We'll have to live on the margins, but I hope conservatively, as we always have and always will. But we do have to watch the bottom line carefully, as you all know. We can live in two ways: income more than outgo, sleep well at night, and be able to invest in something really great when it comes along. Outgo more than income, sleepless nights, misery, and deterioration of the institution. So let's opt for the happier course. So thanks for joining us today, and thanks for joining with us in the next stage of our adventure. It's great to see so many of you here. And now we will hear from our great strength, one of the great strengths of our institution, Sam Fiorello.
Thanks, Dr. Danforth, and I echo his thanks to all of you for coming and welcome. I'm going to start with something unscripted because Dr. Danforth mentioned his days working as a researcher, and I'll tell you a little story. Years ago, early in the history of the Danforth Center, I had the opportunity to go with Dr. Danforth and Dr. Jaworski to visit one of our partner institutions. It was at University of Illinois Urbana-Champaign. And we visited the Beckman Institute, which is a wonderful research institute, and it's founded by the Beckman family, and the claim to fame to Dr. Beckman is inventing some lab equipment, and the original piece of equipment is a spectrometer. So the original, you walk in this beautiful building, and the original Beckman spectrometer is sitting there in the lobby, and it's beautiful, and Dr. Danforth looks at Dr. Jaworski and says, "You know you're getting old when the equipment you used at the bench is now under glass." So again, I want to thank all of you for coming today and allowing me to speak to you. And it's as Dr. Danforth said, it's a great time to speak because we've had a lot of great things happen last year and continue to happen now. So as we gather here for our yearly report to you, in essence our shareholders, I'm pleased to report that in 2010 we once again made significant strides in advancing our mission and are poised by working together with focus and operational excellence to scale even greater heights. Here at the Center, we pride ourselves on striving for and achieving operational excellence in everything we do. This, in turn, has allowed us to conduct great science and use resources very efficiently. Last year, for the 8th year in a row, we outperformed our peer group, maximizing the amount of resources that we allocate directly to support our science. In 2010, 82 cents of every dollar spent at the Center was used directly in support of our science. This versus a 77-cent industry average. Financial sustainability underlies everything that we do. Financial sustainability has both a revenue and an expense component. In order to maximize our ability to achieve mission impact, both sides of the ledger must be managed and balanced. To advance our mission, we rely on 3 crucial sources of funding: grants and contracts, donor gifts, and a draw from our endowment. In turn, we use these revenues to fund 2 categories of expenses: core and programmatic expenditures. I want to focus for a moment on an important distinction between these 2 types of expenses that the Center makes. Again, core and programmatic expenses. Core expenses are those that are not connected with specific projects or activities. They're the costs that will exist before and after a project has been carried out. The ability to cover these core expenses are fundamental to an organization's survival today and in the long term. An example at core expenses at the Center is our investments in our core facilities, our greenhouse, tissue culture, proteomics, microscopy, and soon a bioinformatics core. These Danforth Center core facilities provide scientists with access to state-of-the-art instrumentation and technology which are absolutely essential to their work. They're very expensive. They're expensive to buy and maintain, so no one scientist could afford this on their own. So we provide this to them as a core, and we support that core in order to help them better their work. Another important distinction of the core funding is their ability to have a multiplier effect. Here's an example. In 2010, the Center allocated $2.3 million of its core funds to support our collection of international programs. Because of that strong core, we then were able to capture $5 million of outside programmatic funding from places like the Gates and the Buffett Foundation, the Monsanto Fund, and the U.S. Agency for International Development. In other words, we turned your $2.3 million of funding into $7.3 million of research and development activities to advance the international component of our mission. From our beginning, the Danforth Center has benefited enormously from the vision and generosity of our donors. Gifts to both the annual fund and the Center's endowment have been crucial to the Center's remarkable growth and success. We utilize these critical resources to not only help us fund current research activities, but we are able to use some of these funds to increase our community exposure and investment in growing our donor base. Some examples of these activities include community events such as our many educational outreach programs, the highly successful World Food Day food packaging event that happened last October, our conversation series like the one we'll have tomorrow night here, and numerous public relations efforts. The center is gaining notoriety in the region and across the nation, and that's helping us to continue to grow our donor base every year. A guiding principle of good stewardship is financial sustainability. The Danforth Center's future is ensured by its endowment, the key to the innovation and flexibility that the next years, decades, and indeed century will require. In 2011, the center will, for the first time in its history, begin to draw on its endowment. When this facility is fully staffed with Jim's new hires, and with the addition of our biocomputing core facility, new greenhouse, and a new graduate student training program, we will rely on our endowment to provide approximately $10 million per year to help us cover our costs of our operations. And I love this quote here because I think it's very true, that strong organizations do good work. There are many of them. It's only the strong and sustainable ones that carry that work out into the future. A research institution like ours' ability to capture grant money is a vital part of its ongoing success. Not only provides crucial funding, but is also an external gauge on the quality of our science. At the center, we are fortunate to have some of the world's most talented and productive scientists, and they continue to excel in winning competitively awarded grants and contracts. To date, we've booked $11.8 million in grants and contracts for 2011. This, on a base of 15 principal investigators, translates into over $750,000 per investigator, or better than 2 times our peer group average. I'm pleased to have been able to report to you that in 2010 was another great year for the center. We achieved important financial and operational milestones. But as Senator Danforth said in his remarks here at the center on January 7th, it's not about dwelling on the past, but rather asking, what's next? In 2011, we look forward to building on our strong institutional base. We look forward to Jim Carrington's arrival and his leadership in growing and diversifying our scientific activities, which will leverage that strong base. Here are some examples of the growth we foresee in 2011. Later this quarter, we will break ground on a major greenhouse expansion projects that will add 70% more capacity to that core. Also in the coming months, we will begin an expansion of our tissue culture facility, an addition of 50% capacity to that core facility. This year, we will establish a biocomputing center, a vital new core facility that Jim will bring to the center. In 2011, we will continue to establish ourselves as the go-to place globally for field testing, including the development of a field research station in South Africa, working with Howard Buffett and his foundation. Finally, we will work with Jim this year and in the coming years to establish a truly robust graduate student program here at the center. A key part of the vision of the Danforth Center from the beginning has been to be a catalyst to St. Louis for it to become the worldwide hub of plant science. The success of the first phase of Bridge Park is making that vision a reality. Building 1 continues to add occupants with 6 tenants added in 2010 and 3 new tenants expected in the second quarter of 2011. As occupancy levels grow, we will finalize plans for Building 2 in hopes of, within a year or 2, beginning construction on that second phase of our project. In 2010, the Bridge Park was the founder of the Global Ag Tech Investor Network, or GAIN, an organization that promotes capital formation, raises awareness of ag tech investing opportunities, and provides a forum for strategic partnering, joint venturing, and acquisitions. 2010 was another great year for the Ag Innovation Showcase. The Showcase, an annual 2-day event created by Bridge Park and the Danforth Center, has become an important event in the ag industry. Ag industry leaders, entrepreneurs, venture capitalists, and investors from around the world gather here, again for 2 days, and talk about issues of importance in the sector, and it's a wonderful way for them to build networks. And this year, we're going to have the Ag Showcase here again, and it'll be May 23 and 4, and it's looking like it'll again be bigger and better, and it's very exciting. It's really gained some momentum. Finally, I'd like to extend my thanks to those who really make this place work. I will start with our administrative team, who work every day to make this institution excellent. I want to thank our scientists who are dedicated to their work and to our mission. I want to thank Phil Needleman for his leadership. Phil's a terrific person who I've enjoyed working with and learning from every day here. I give thanks to the Danforth Foundation for their incredible generosity, not only with the latest gift, but for all their support since our inception. I want to thank Dr. Danforth for his unwavering leadership, wisdom, and support this year and every year since I've been associated with this project. And of course, I want to extend my heartfelt thanks to all of you, our supporters. Without you, none of these accomplishments would be possible, so thank you very much. And now I'll ask Phil Needleman to come on up.
No slides, no script, stream of thought. I can't believe it's a year from the time I stood up here and said, you know, I came here as a mammalian biologist with 50 years of research, and the only way I could cope was that I decided to plant as a person that couldn't move. Now I understand an interim president is a person who could move. I'll talk about three things. You've really captured the essence of a good year. I'll talk a little bit about the people, talk a little bit about the future. The metrics, what is an interim president good for? Keep the momentum, smooth out the organization, facilitate the search, let the new president just focus on the most important things. Actually, I think an interim president is the agent of change. You know, you come to organizations and they've done things for many years and you get a lot of, this is the way we always did it. And you don't go back and test, because especially if it's going well. Well, being an agent of change in a place like this is really a pretty easy process. My discipline is pharmacology, about drugs. The body recognizes the drug. There's a concept of a key, which is the drug, and the reaction site is the lock, and you have to turn it to make it work. Technically, it's the ligand, and the lock is the receptor. And I know you can't be a ligand without a receptor. Here, it was really acceptable and willing to look forward. The metrics you've seen, science flourished. Research grants really made a difference. Without saying the names, there's a whole set of junior scientists that are called assistant fellows. Without me actually saying it, they showed their independence in their own career. The fundamental science flourished not just with grants, but with really outstanding publications. Then the big kind of science around improving the human condition and the sustainability. Two kinds of programs. The programs related to alternative energy around algae really moved to the operational place with large syndicates of institutions collaborating aggressively in really large grants with multiple universities, the Department of Energy, and scientific institutions. So the funds were there, but the execution. Now I just think about the last week or so. I sat in earlier on the week on our great program to try to change the human condition in Africa, the bio-cassava program, or the viral resistance. The stream of discoveries that are important, the relevant genes, getting into the relevant landforms, the stacking of genes, that science and fundamental science has flourished. What I see now is a real maturation of the program that does the developmental research that moves an idea into Africa and into African hands. You know, there's a lot of science about the level of extraction, the statistical power, the regulatory issues. That's really changed this year. Last week on this stage, Kathy Kahn, who's the Bill and Melinda Gates Science and Technology Officer, said, you know, it's only the Danforth Center that could do this. Academia can't do it. Industry doesn't do it in certain areas that are restricted to nutritional things in Africa. You should understand they're still the enabler. And so the recognition of the Danforth Center as the go-to place to do translational research really has matured in the year I've watched. Now, about the people. The rock of the Danforth Center is Bill Danforth. He is the rock of this institution and nearly every kind of important institution in this city. To work with him, he and I go back almost 50 years, when neither of us wanted to pay the $30 a year parking fee for the medical school, and we parked in the Steinberg rink lot and walked up to Bill, I know why I couldn't pay. I knew him only a little bit as an investigator. I knew him as a vice chancellor, I knew him as a chancellor, and I was a member of the executive faculty. This is a guy who's so bedrock in what's important, who is the innovator who sees over the horizon. And like most of you, if Bill Danforth says it's important, we say yes, and then you tell us why. Secondly, there's two people who I work with very much every day. Sam Salvatore Fiorello and Allison Brown, two really wonderful people. Sam, there was a system where you met every few weeks. Sam and I would have coffee every day and deal with any issue, people, finance. It was just, like many people here, there's just inherent trust. And then the junior investigators, the senior investigators, you know, she won't like it, but like, take Toni Kuchan. She was recognized this year to become a member of the prestigious German Academy of Science. She won the St. Louis Academy Fellow Award. Now she's even honored by the Girl Scouts. There are people here who are citizens of the institution that really make a difference. The side things besides the science, that wonderful World Food Day, the Leadership Council, the Education Program, the Ag Innovation Showcase. Sam didn't just have almost 300 people. He had people competing to present their ideas. And no place else in this city do startup companies draw venture capital from the East Coast in the West Coast. That's part of St. Louis will be the center of plant science. The last part is the search. I've searched for department members, for department chiefs, for deans of medical schools, part of chancellors, heads of universities. This was the most interesting and best search. Roy Vagelos was a giant, the consultants were a giant. For me, I wanted a guy who was smarter than I was, faster, could organize 12 numbers into a clock so they could really manage an institution, and had a sense of humor. So you know Jim's credentials. You'll know the power of computational biology and genetics at a transition state in science. But yesterday, he had 3 candidates here. One gave a seminar, 2 gave a chalk talk about what their research is going to be. It won't be just what he talks about, high power computational power and genomes. They talked about what you'll do with those tools. One person wants to convert C3, C4 plants, so they optimize. They change the way a plant will deal with oxygen and CO2. They'll change the fundamentals of water. They'll really map the information that will be about science. So they weren't fixated on the tools, they were fixated on the problems. Well, Jim, by discipline and by his disposition, I think is the finest result of a search that I've seen. And I think we're lucky to have him. And I'd like to introduce him now, Jim Carrington.
Here, I'll now do something that will show I'm really a humble guy. I just learned about that button this morning. Well, I don't deserve that introduction, but thank you very much, Phil. It's a real honor to be speaking after each of the other speakers this morning for different reasons. First, speaking after Bill is a challenge. I've mentioned this before the last time I was here, and if you put Bill and his brother together and then have to speak after both of them, it feels a little bit hopeless. Phil referred to Bill as the rock of the institution. I've never thought of him as the rock. I've always thought of him as the heart of the institution. So you're the rock and the heart. You're probably a few other things as well, Bill. I'm fortunate to speak after Sam because Sam gave you the nuts and bolts about why this center works as well as it does. It's about the money, but much more importantly, it's about the people that are using the money and that are raising the money. And I think, Sam, you gave a great overview of that, and you gave it not only with the facts, but I think you did it, people have a feel for the personality and the spirit of the institution. And it's great speaking after Phil. Phil, I need to thank you again for the work that you've done over the past year plus. The center would be in it'd be in a very different place if you hadn't stepped in. And I very much appreciate it, as does everybody in this room, in this building. I'm also fortunate to be able to not talk about the past. I can talk about things that are much more fun and entertaining. That's the future. Somebody once said, the problem with the future is it's so hard to predict. But what I'm going to do is focus all of my comments on what you're going to be seeing over the next few years. In fact, these things are happening now, and I'll mention those as we go along here. I want to also point out that there will be nothing magical about May 1st when I start officially here. You're not going to notice anything different. Much of the work that I'm going to be involved with seriously has already begun, but the institution is not going to change significantly on May 1st. We'll show up about that time. I'll be bringing my wife, Terry, who many of you have met, and a lab with about 7 or 8 people. My current administrative assistant, Goretti, who's with me on this trip, will be coming. So we're looking forward to it. Now, what's going to be happening over the next few years? It's already happening now, as I mentioned. Let me lead off with what I view as the most important thing that I'm doing right now as it relates to the center, and that's hiring a new round of investigators to fill out this building. As was mentioned previously, hiring has been a little bit slow over the past year and a half or so in anticipation of the next president. The next president is on board, so we are moving at full speed ahead, or as my good friend Tony Kuchan says, with lots of moving parts. The lots of moving parts is we're trying to hire 5 new scientists all at once. Let me give you a brief progress report of how that's going. As Phil mentioned, we have 3 people here today, yesterday and today, who are either interviewing for the first time or are on second visits. We're very interested in them, and we're actively recruiting them. They gave fantastic presentations yesterday. Phil mentioned the exciting science that they're doing. I'm not going to overview their science, but let me just summarize and say they're fantastic people. These are the types of people who we're looking for, and let me just describe what the ideal candidate is. The ideal candidate that we are searching for is addressing the biggest problems in plant science. What are those problems? They will answer how the genetic composition of a plant gets translated into a phenotype. Now, what that means in layperson's terms is we want to understand why plants grow the way they do. We want to understand why, when you put plants in the ground and then withhold water under drought conditions, why some plants survive and why some plants die. That has a genetic basis. We want to understand why, when you take two varieties of a plant, like corn, and cross them, why the children of that cross grow so much larger than the two parents. Many of you know what that's about. That's called hybrid vigor. There's a genetic basis for that. We can understand all of these things. The idea is, if we can understand the basis, what's happening at the molecular, the biochemical, and the whole organism level, we can manipulate those traits and properties and make plants better. Those are some of the big questions in plant science that we want our new faculty to address. The new faculty need to bring something new into the center. That's technology. If they were doing only the same things we were doing now, we'd be losing out on a huge opportunity. It's the influx of new talent that brings in new technology that makes a big difference in advancing the technological capacity of the center. Now, what happens is you get great people that are using technology. That's great for them. But if they fulfill one of the other criteria, integrate with the culture of the center, that technology infuses across the center and everybody benefits. We're also looking for people who are functioning very comfortably at the interface between plant science and computation. Now, why is that important? I've had a lot of people fascinated by this idea of the need for high-powered computing for plant science. These are plants, so you put them in the ground. What's so computational about that? Well, science these days involves massive amounts of data. I'll show you a couple of pictures and even some movies in just a moment of some of the machines generating these types of data. We can't even look at the data. The nature of data now is at the terabyte level and the tens of terabytes of data. They are at the hundreds of billions of data points. We never see the actual data. We see abstractions of the data. Now, what that means is we need computers to do the work for us. But what that really means is we need people who can function in the computational space. That's why it's so important that this next round of hires brings in a very heavy computational emphasis. We'll have scientists who are never going to see a laboratory bench. When I grew up in graduate school, I'm still growing up, by the way, but when I was younger, in graduate school, as Bill mentioned, all of our work was done with petri dishes and with pipettes and with things that we could see, and all of the results of our experiments we could see with our eyes, and we could understand what we were looking at. Well, we can't understand what we're looking at now because the data sets are too large, and the people who are skilled at analyzing these types of data may never even see the laboratory, but they need to work comfortably and productively with those at the bench. So those are some of the characteristics of individuals that we're looking to hire. Now, one other characteristic I mentioned briefly, integrating with the culture. This is important because I don't want to give you the impression that we're in the technological backwaters here. We're absolutely not. We have some fantastic people here working in lots of areas, lots of high-tech areas. But the idea is to bring in new sets of technology to make those individuals even more productive, and they in turn will facilitate progress and discovery of all of the new people we bring in. Now, as a by the way, we have an important mission in the Danforth Center to promote economic development around plant science in the St. Louis region. It is not insignificant that 5 new investigators means roughly about 50 scientists are going to be recruited here. Once these labs are up and running, a typical size lab is going to have something on the order of 10 people. These are highly skilled, hopefully reasonably well paid, but these are talented people, some of which may stay, form companies in the St. Louis area, be faculty in the region, otherwise be productive people, the type of people that we want to bring here. Now, a little bit more about technology and computation. We are not going to be doing this on our own. We need to reach out and collaborate with other people, other groups, and other institutions. I'll point to one. Washington University across town has phenomenal capacity and talent in this new computationally intensive bioscience space. In particular, I'll mention Jeff Gordon, who I've been working with very closely and have become friends with. Jeff runs the Center for Genome Science and Systems Biology, centered at the med school. Jeff has been extremely enthusiastic about the Danforth Center gaining access to their vast computational resources, access to their scientists and staff, as well as their instrumentation that's primarily focused around genomics, being able to rapidly determine genome sequences of new organisms. You know, you all know about the Human Genome Sequence project, which was a major undertaking, a major technological feat. But frankly, when you talk about sequencing a genome today, it's no big deal. What we talk about instead, as one of our candidates yesterday was working with, we talk about sequencing 50 genomes, 50 varieties of a plant, because the type of information that you gain by sequencing 50, or as my friend Detlef Weigel is doing, sequencing 1,001 varieties of a plant. By the way, it's 1,001 because Detlef wanted to outdo the 1,000 Human Genome Project. And I convinced him that the plant scientists are at least 0.1% better than the human scientists. The information that you gain from sequencing 1,000 genomes is fundamentally different than what you got when you sequenced the first plant genome. So the scale of what we need to do is going to require collaboration with other institutions that have massive capacity. It's going to require new technology being brought here in the center as well. You've all taken tours of the center. I hope you do so over the next year or two, because you'll see some new toys, as the scientists call them. Some of these are going to be robotics, others are going to be other types of instrumentation that use technology that didn't exist just a few years ago. I'm showing you a movie here not to explain to you how we sequence genomes these days, but just to point out that the technology that we can import, combined with talented scientists, can do great things. Now, as with all new technology, whether it's communication technology or bioscience, plant science in particular, as I mentioned, this is data intensive, which puts a huge premium on computation. I'll come back to that in just a moment and how we plan to train new people in the future to do this. I want to come back and underscore one point I made previously. We're not in the technological backwater here. We have a lot of cutting-edge tools that have been developed and implemented here in the center. I'll point out one set of tools in our mass spectrometry laboratory that Leslie Hicks runs. I don't know if Leslie's here, but Leslie is fantastic. I know many of you have met her. If you're interested in how we analyze the machines and the chemicals inside of plants at extremely high resolution and now at increasingly high throughput, go talk with Leslie and see her facility. It's absolutely spectacular. Proteomics, metabolomics, these terms that end with "ics" are frequently used to describe these types of new technologies that we're employing. Now, coming back to the need for computation, it's not just about getting more computers or faster computers. It's about getting and training people who are doing fundamentally different types of science than those of us who were trained even a few years ago were doing. This is Noah Falgren. Noah is going to be coming to the center here. Noah was a graduate student in my lab who taught himself how to do programming. This is not uncommon. Biologists who saw the need, based on an interesting problem, saw the need to develop on their own the tools because there was insufficient capacity of the institution that he got his PhD at to train him how to do the work that was necessary. We need to change that, and one of the ways that we're going to change that is to ramp up our participation with our partner institutions, Washington University, University of Missouri, to name two. We need to ramp up our participation in their graduate programs, get their graduate students funded, supported, and trained in the Danforth Center. There have been a number of students that have come over from WashU, Washington University, and other universities that have been trained here in the center. We need to grow that, and we need to do it for several reasons. First, this is the next generation of scientists that need to be addressing these big problems that we're talking about. But second, an institution the size of the Danforth Center needs youth in the form of graduate students. These are the lifeblood of institutions like this. They come in as young, enthusiastic people. Many times they come in with sophisticated skills, other times they come in with fewer skills. They come in with the craziest ideas sometimes, but in my experience, the graduate students are the ones that ultimately have the largest impact in some laboratories. So we need to build up the resident graduate student base here. And I can't underscore enough the importance of the gift from the Danforth Foundation. This will be one manifestation of how we're turning that gift into real activity here. These students will be trained not only in plant science, but in technology, computation, and very importantly, they'll have exposure or they'll be working directly in taking discoveries that are made here and elsewhere and translating those into meaningful applications in places in the world where it makes a difference. Finally, let me end here and just give you a few quick thoughts about the future and some of the needs. First of all, we are going to need to increase the size, and I think that's going to increase the impact. These two things are intertwined. We need to, you've already heard about a few of the physical facilities that are going to expand. We have the greenhouse expansion that after touring it with our candidates yesterday, I can personally vouch for the desperate need for additional plant growth space. But longer term, once we get that project underway, the possibility of needing additional space for laboratories is going to become an acute need at some point, possibly in the near future. The types of individuals and the capacity that we would like to build will have an impact on diversifying our programs. So the impact in international agriculture is very focused right now around cassava and a few other projects. I think we need to expand that because of the needs that we see around the world. In the biofuels arena and renewable energy, we have considerable strength here and a very high profile in algae. There's the possibility that we can expand the portfolio of projects that have direct impact on renewable energy. The funding base for the center is going to need to continue to diversify. There's one big reason for this, and that is what's going on at the federal level. You all are in tune with what's happening at the federal budget level. Science is one of those items in the federal budget that's on everybody's chop block. It is viewed as a purely discretionary item by most legislators. This is something that, as citizens, you can get involved with directly with your representatives, but it underscores a very important role for all of you here. We are going to be not less dependent based on the Danforth gift, but more dependent on in the future on the generous work, the volunteerism, as well as the donations of the friends, and all of the associates, volunteers, staff in the Danforth Center, around the Danforth Center. This is a very important group here. That means we're all in this together. I really look forward to seeing all of you on a regular basis. There's faces that I've seen many times now in the short interval that I've been associated with the center here. You're a wonderful group, and I'm not saying that just to flatter you. I'm saying that because I'm genuinely impressed with the type of individual and the quality of person that's choosing to associate themselves with the center. So thank you very much. I'm going to turn it back over to Bill for some closing remarks. Thank you very much.
I don't know there's much less to say in closing, but we're certainly open to questions, comments, be interested in your responses. And we do have microphones ready to get close to you if you raise your hand. Yes.
Pardon me, but I don't understand how in the world you can put a number to a cell or a plant. What numbers are you computing as far as, say, the genome, the proteomics, the cell itself?
Now that gets right to the heart of the matter.
Yeah, I don't know. Frankly, I
I'm
don't
going to see
understand.
how well people have been paying attention. So Sam, I'd like you to answer that question. Yeah, that's a great question. Here's another way of asking that question. What does digital plant science mean? Because that's essentially what you're asking. So the technology that we have access to today and that we can develop here in the center will enable us to do things like the following. Let's say that you're interested in how well a plant responds to drought stress. All right? You plant a bunch of corn plants or soybean or model plants like Arabidopsis. You plant out hundreds of these and you give some a lot of water, some a little bit of water, and some no water, right? No digital data yet. However, doing it with 100 plants is simply insufficient to get all of the information that you really want. You want to do this with hundreds of thousands, if not millions of plants. The way you do that is you do a process called high-throughput phenotyping. What that means is you let a camera take a picture, or you let a machine take a spectrographic profile that measures some visible or even non-visible emission. You have sensors that can measure the temperature. It's all done electronically, it's done robotically, and it generates a massive amount of data. And if you're running the experiment, you might not ever even see the plants because you have technology specialists who are running this phenotyping platform. And what you will see is output on a computer screen. You won't see pictures of plants. You'll see numbers that represent the size of a plant, the temperature of the plant, the changes in pigmentation of the plant, the chemical composition of a plant, if that can be measured at high throughput, perhaps the volatile composition. Okay? So these types of important properties or traits can be turned into numbers, and once they're turned into numbers, the computational biologists, the mathematicians, the statisticians, and the other quantitative scientists get to work.
That's exactly what I would have said.
That's just one example.
I just give one other example is if you are a close follower of baseball, you know that some of the coaches, particularly some of the younger people, are trying to figure out how better to predict how players will do. And they do it with numbers from past experiences and so on. And numbers are really entering everything. When a marketing company wants to sell you something, they keep track of the data and numbers and computers. It's a very, very powerful tool in almost all of our walks of modern life. Any contrary views? Anything else? Oh, yes.
Thank you. Is a large part of the effort that the Plant Science Center puts forth devoted, or some percent of effort devoted towards converting some of these neat finds into practicable agriculture? So for example, you come up with drought-resistant rice that, by the way, has terrifically high nutritional content, for example. With the sensitivity of the European countries to GM, genetically modified plants, and Argentina, for example, is it difficult to get these things into practice in agriculture? The United States is a little bit more susceptible towards accepting scientific formulations in food.
Yeah, well, that's you touched on many, many different important issues that we can talk about. Let me just briefly touch on a couple issues. First of all, the unique mission of the Danforth Center is to take basic, fundamental discovery that is done here or is done elsewhere, and then to enable the translation of those discoveries into meaningful applications. And I can give you many examples of such work that's going on here. I mentioned a few. And I can't stress how unique that is to this institution. The mission of the Danforth Center is to improve humanity through the use of plant science. And we've identified food security, renewable energy as the two fields where we can have an impact. Now, relating to the translation to commercialization, which is not at all antagonistic to non-commercial applications that you would see, for example, in underdeveloped countries. The role of the Danforth Center in commercialization is extremely important. We secure intellectual property that provides a route for commercialization. As you know, without intellectual property, it is not possible to commercialize anything in this country or other countries that function through a commercial economic system. That is not exclusive of donation of that technology to the underserved. Okay? Now, as far as acceptance of GM crops in places like Europe, this is evolving. This is not a static situation in Europe. It's not a static situation anywhere. Our job here is to do the best science that we can. If the science tells us that a approach to crop improvement has vastly more benefits than potential risks. As scientists, we're somewhat obligated to pursue that from the scientific perspective. Now, risk assessment, implementation of technology, getting past regulatory barriers and hurdles is also something that we do here, and we do it uniquely in the field of plant science. In particular with our agriculture, or our international agriculture programs. Paul Anderson runs a fabulous office that's job is to take discovery and figure out how it can be implemented in a safe, in a transparent, and a socially acceptable way. So these are things that we think about a lot. There's a lot of work. We actually go out and get grants to support those types of activities. And again, it's a unique part of what the center does.
Okay, well, thank you.
We got one more.
Is the regulatory control system internally developed, or is there some outside organization or governmental system that controls the transformational aspects of gene transfer and so forth? The reason I ask is that I have a friend who's he's now retired, but he was in this business for a long time, and he said he heard of an instance once where researchers were trying to transfer the genes from poisonous amphibians into plants as a means of disease control, insect prevention. And he warned them very strictly, in his position, he was a rather senior man in the area, that they were playing with fire when they were fooling around with something like this, because if that were to get loose into the environment, why, it might cause all sorts of very, very bad consequences. So I was curious as to what the regulatory control system really is over the research and
Yeah. Well, that's a good question. Again, it's a complex question. In the United States, we have a fairly regular and predictable regulatory structure, and it involves several agencies at the federal level, including the FDA, the EPA, to assess effects on health, if it's a consumable, and effects on the environment. Now, if I can assure you, if somebody tried to put into a commercial pipeline or plant out in the field plants that had known toxins, particularly toxins that had an impact on humans, there is ample regulatory control for that type of thing. Now, we don't need to develop all that much expertise at that level in dealing with the U.S. regulatory system, because again, it's a fairly regular, well-defined system. Where we do need to put a lot of emphasis and a lot of effort is at the international level in underdeveloped countries that do not have a functioning regulatory system to do the types of approvals and the types of assessment that we're set up to do here. To do a field trial in one country in Africa is a major undertaking because they haven't done it. And the rules, I don't want to trivialize it by saying the rules are made up as they go along, but the routes whereby a field trial needs to go through and the connectivity that needs to be established and developed to do that. The scientists at the bench are ill-equipped to do it. It's a full-time job of people who have expertise and commitment and a willingness and a drive to do that.
Let's see, we had a question over here. No?
Maybe just time for one more.
Is there one more question? See any hands? Thank you all very much, and stay tuned.
Thank you.